Say we have an image like this randomly generated 5x5 grayscale grid, and we want the computer to be able to tell us whether or not it thinks that the image contains a dark ring. A good way to do this would be to tell the computer where we expect black pixels to be and where we don't. We assign each pixel a value based on how dark it is, and then multiply that by a number based on how much we want the pixel to be black. Pixels that we definitely don't want to be black, like this one, could be multiplied by a negative number, and pixels that we don't care about can be ignored or multiplied by 0. Now when we add up all these numbers, we get a score. A greater score indicates a more prominent ring. This is great for the very specific task of identifying a ring centered in a small image. But what if we have a larger image that could have many rings all over the place? By applying the original function, or filter, to every pixel, we can create a map of where the computer thinks rings are centered. What if we applied a new filter to this map, such as this one, which looks for two dark spots with a pixel between them? Well, now the computer is able to identify the number 8. How about combining the results from two filters, our ring filter, and another which looks for straight lines, to identify the number 9, or the letters D and B? This is the basic principle of artificial neural networks, an incredibly flexible type of machine learning inspired by the biological pathways of the brain. Each pixel is an input, and these inputs affect a collection of nodes, or neurons, which are the pixels on our map. The amount by which each pixel affects each neuron is the weight of that connection, like the multipliers in our filter, so every neuron is a result of a different filter being applied to the input. The power of a neural network comes from the numerous layers of neurons within it, every neuron from one layer connecting to every neuron of the next. In practical applications, neural networks are far more complicated and diverse. Unlike ours, where filters were manually created, they could be trained by giving the computer training data, which isn't limited to images, and scoring its outputs. The learning algorithm randomly changes some of the weights in the network, and tries to work out which weights need to be changed to improve the score. The result is a complex network, evolved to robustly perform a certain task, but in a way far too abstract to fully comprehend, much like a real animal brain. The score of an output can be calculated by comparing it to an expected output, and once the network is trained, it can be used to identify unknown data. If you've ever wondered why Google's reCAPTCHA system is asking you to select all the images of cats, or type the number on a door, it's because you're training its neural networks. Similarly, NASA's Galaxy Zoo got users to classify millions of galaxies from the Sloan Digital Sky Survey to train their own AI. Sometimes an expected output is not already known, and the score is instead based on how well a generated pattern fits the data. Amazon uses this type of learning to predict what customers will want to buy based on their browsing and purchasing behavior, and CERN uses this pattern finding to find anomalies in the petabytes of data produced by the Large Hadron Collider, and to organize the results into something more useful to humans. We're at a point in computing where a hobbyist can train a computer to play Mario or recognize languages, whilst academies and research groups have been simulating human voice, making trippy, dreamlike images, and even faking footage of people speaking. The emergence of quantum computing promises even further advancements, and machine learning is now a ubiquitous part of any study with masses of experimental data. And yet, ironically, with every step forward in the development of artificial neural networks, we take a step back in how well we understand what's going on under the bonnet. For the first time, humans can't fully understand how the tools they're making actually work, which could lead to quite a scary future.